Hi everyone, I've got multiple questions from students this week about Module 2, so I thought I would do a few of the common questions just to help some of you guys out before you take your Module 2 quiz and before our exam that's coming up next week. So the first couple of problems are about compound inequalities. This first one is an AND inequality, and it's very important to pull out a colored marker or just do something to make sure you're looking at that word in between the two inequalities and knowing what it means. So an AND means an intersection, which is going to, I'll use the phrase the overlap. What the two have in common is the overlap. So we're going to solve each one of these and then find what they have in common. So I'm going to quickly solve each one. 2x is less than or equal to 6. And then I'll divide by 2 on both sides. So x is less than or equal to 3 is the first one. Let's solve the other one. 4x is greater than 4. Divide by 4 on both sides. X is greater than 1. And then I'm going to draw a number line because drawing it and plotting it on a number line will help me visualize where the overlap is. So let's see, let's draw 1 here and 3 here. I'm going to get some colors to help with this. So I'm going to start with yellow for this one. Let's draw x is less than or equal to 3 in yellow. Ooh, yeah, let's do yellow. Okay, so less than or equal to 3 is going to be a closed circle on 3 because we're including the 3. Then we're going to highlight everything that's less than 3 going on to the left. Let's go ahead and change that color, I don't know, to pink. And let's go for the next one. X is greater than 1. Greater than doesn't include the 1, it's just all the numbers bigger than 1. So we show that with an open circle here, and we head to the right. Now I tried to use some colors so you can see the color overlap, but we just want the overlap. Our final answer is going to be whatever you kind of see in orange here. So I'm going to start at 1, not including the 1 for my interval, where the overlap is, because I can see that only 1 is highlighted in yellow. It's not really highlighted in pink because we did an open circle there. All the way to where it's orange, all the way up to closed circle on 3, that's where both of them are highlighted there. So all the way from 1 to 3, including the 3, but not including the 1, is the overlap. And so that is my AND compound inequality. That would be my solution set. That would be the solution set for both. Okay, going over to the next one. This is one my student sent. And let's notice what word connects these. This is an OR. This is an OR, so this means something totally different. This now means a union instead of an intersection. And so a union means keep everything from both. Not just the overlap, but keep everything that's in one or the other. Not the overlap, but keep everything that's in one or the other. So as I solve this one, I'll solve each one individually. Negative 2x is greater than or equal to 2. Divide by negative 2. Oh, we divided by a negative, and I know the rule, and hopefully you guys do too. If you ever divide by a negative when you're dealing with inequalities, divide or multiply by a negative, I want a big flag to pop up in your head that alerts you to the fact that something unique has happened here, and we have to switch the direction of the inequality sign in order to keep this inequality true. If you do not remember to switch the direction of the inequality sign, you've now created a false inequality and you'll get it wrong. So if you've divided by a negative or multiplied by a negative on both sides of the inequality, we have to remember to flip the direction of the sign. Okay, so I've solved that one. You have the OR word brought down. I'm going to solve this other one. Divide by 2. X plus 4 is not less than or equal to, just less than 5. Minus 4 on both sides. X is less than 1. Okay, I never divided by a negative. I never multiplied by a negative, so I never had to switch the direction of that sign. Now let's visualize this one. I have 1 over here. I have negative 1 over here. Let's get some colors out so we can see. I'm going to do yellow again with this one. So less than or equal to negative 1 means we're going to close the dot on negative 1 and head to the left. let's go with pink for this one. This one's just less than 1, so I'll open the dot and I'll head to the left. Now, if we were looking for the and, I would be looking for the orange where the overlap is, right? But I'm not. I'm looking for the or. I'm looking for the union. I want to keep everything from both. Everything from both. And it looks like there might be 2 intervals here, but really there's just one interval. That if we can represent everything from both by saying everything from -1 down to -infinity covers everything from both, right? I've just highlighted everything that's either pink, yellow, or orange, everything from both. So this final answer needs only one interval from -infinity to 1, round that 1 bracket because we're not including the 1. Okay, so that's compound inequalities. Let's quickly move on to the next couple, which are absolute value equations and inequalities. With absolute value equations, some people I've noticed have been setting these up incorrectly. I do want to make one big note that absolute value equations or inequalities must have 2 cases when we solve. But that doesn't mean we set up the 2 cases right from the get-go. We first have to isolate the absolute value stuff. Everything I've put in yellow here needs to be on its own side before we set up the 2 cases. So let's do that to set up the before we set up the 2 cases. I also want to note, look at this 3 minus 5. I don't want anyone to write a -2 there. This 5, this -5 that's next to the absolute value sign is actually being multiplied. So we don't actually want to, order of operations tells us not to subtract before multiplication. We don't actually want to subtract those. So I'm going to start moving things to the other side. I'm going to do that by, let's see, subtracting 3 as my first step. And then I'm going to have -5 times absolute value of 5x plus 3 equals -25. I'm going to divide by -5, again, because I'm trying to get the absolute value stuff alone. And now is when I'm ready to split off into the 2 cases. And I'm going to highlight this stuff in yellow and talk real quick about why we split off into the 2 cases and why I just put a big, huge must up here. So absolute value talks about distance from 0 on a number line. 0 is right in the middle. Distance is measured in positive units. That's why absolute value is always positive. So this is saying the yellow stuff, whatever, we want to find an x that would make this yellow stuff, the 5x plus 3, 5 units away from 0. 5 units away from 0. Well, there's 2 directions from 0. There's 5 and there's -5. So this yellow stuff, I keep calling it the yellow stuff, but the stuff inside the absolute value could actually turn out being equal to 5 because 5 is 5 units away from 0. But also this yellow stuff, the stuff inside the absolute value, could end up being equal to -5 because that's also 5 units away from 0. So I split it into these 2 cases based on the meaning of absolute value. And then I go ahead and solve each one. So -3, 5x equals 2, divide by 5. So I get one of my solutions is x equals 2/5. The other one, I'm going to -3, 5x equals -8, divide by 5. My other solution ends up being -8/5. If you're not getting 2 solutions, you might be doing something wrong. There are times when you might have an absolute value equation that gives you no solutions at all. If an absolute value is equal to a negative, with the absolute value signs there, if it's equal to a negative. But other than that, we need to get this absolute value alone on its own side. If it's equal to a positive value over there like it should be, then we split off the inside stuff into the 2 different cases and solve. Okay, last one. This is an absolute value inequality. So I'm going to start kind of like the last one. I want to get the absolute value stuff alone. The stuff that's inside the absolute value, I got to get that alone on its own side. So let me rewrite it, whoops, over here. And start moving things to the other side. So -2 from both sides. We'll have 2 times the absolute value of x minus 7 is greater than 4. I'm going to divide by 2 on both sides. I get that the absolute value of x minus 7 is greater than 2. Again, think back to my number line and what absolute value means. That means that the inside stuff, the stuff I have in yellow, we want to find an x that would make the inside stuff, once I plug this x in, I subtract 7 from it, I want it to be more than 2 units away from 0. More than 2 units away from 0. Well, I'm looking at my number line. I'm thinking about, let's get me, well, it doesn't want to switch. It wants to keep it as a highlighter. I'm looking at my number line, and 0 is right here, and 0 is right here. So I'm thinking of, okay, more than 2 units away from 0. That could mean anything bigger than 2 is more than 2 units away from 0. Anything less than negative 2 is more than 2 units away from 0. So when I'm looking at finding when x minus 7 is more than 2 units away from 0, I have 2 cases to set up. Let's set up this one first. I can set up that x minus 7 could be greater than 2, because that would give me this stuff right here. Or the other one, I could say that the x minus 7 would be less than negative 2. So notice the difference between both of those. This is the less than negative 2 interval down here. So even before I solve this, I know my answer right here has to be 2 separate intervals, not just one interval, because we're looking at the places on the number line that are more than 2 units away from 0. So then I can go ahead and solve these. Let's see, I'll add 7 on both sides. X could be anything less than 5, or add 7 on both sides. X could be anything greater than 9. Greater than 9. So that leaves me with the 2 intervals from negative infinity to 5, union 9 to infinity. Any number I pick in those intervals to plug in the x spot of the original equation is going to give me a true inequality. Give me a true inequality. So I hope that was helpful.